So I am currently talking to Cliff from James Fisher, who is head of HSSEQ, or Health, Safety, Security, Environmental Quality, to learn a bit more about how cargo is safely transported around the world. Would you be able to introduce yourself and maybe give us a brief background of your time in the industry and how you got into your current role?
Yeah, my name is Cliff Roberts. I'm the head of the HSSEQ team. I've been working for James Fisher for 23 plus years. I spent 17 years at sea. I sailed on all different types of ships to the rank of master. I gained experience in STS, ship-to-ship transfers, dockings, personnel transfers. I've got a variety of ship experience, so crude oil, clean and dirty products, chemicals, LNG, dry bulk, and some passenger ferries. Since being ashore, I've managed quite a lot of contracts that we have within the group, and that goes from irradiated nuclear fuel carriers through to the terminals and the various cargo transfers that we do, sometimes in port. So I've got several roles that I fulfill. I'm the designated person ashore, which is a legal position under the ISM code. I'm the security controller. I'm also the environmental officer as well. So
Great, thank you. Now, Cliff, during my time on board, I got taken on a tour of the engine room by Sebastian, the engineering cadet. And one thing that really stood out to me was how much health and safety equipment and regulations underpin every single thing that the crew does while on the tanker. Can you talk a bit more about some of the main regulations that you have to comply with, as well as what that means for the crew and for yourself?
yeah, it's the onboard team under the direction of the master. They have to comply with a whole suite of regulations and statutory instruments, as they're known. Some of the main two that spring to mind are the SOLAS, Safety of Life at Sea, and MARPOL, which stands for the Marine Pollution Regulations. For example, SOLAS came about after the Titanic incident, when they didn't have enough lifeboats for everybody. So after that, it was decided that they needed to bring in regulations to help ships and ship staff in event of an incident. So those are the main two regulations that have been going for a long time, but there are many, many others, including STCW, which is the standards of watchkeeping, and many other regulations that they need to follow. We give them guidance in what we call there's a manual on board, which is the company safety procedures manual, and we go into the regulations, identify what's required for that particular ship and that particular trade, and we put that regulation there, so they don't have to go and look at the regulations online. They've got what they need, where they need it, when they need it.
So very specific efforts that you have to make for every single voyage. Did I get that right?
It's not for every voyage. We do it for every vessel, and that covers all the voyages that vessel will be able to undertake. So there'll be, for example, some ships are trading around the UK and Europe, and they have those regulations. Some of the ships trade further afield into the Caribbean, and some of them are worldwide. So it depends on where the ship's trading as to how much of the regulations they need to comply with. Also, when they go into territorial waters, they need to comply with the state's territorial waters regulations that's in place at that time. So, for example, the ships trading within the 12-mile limit, they'll come under the UK health and safety regulations.
On the voyage, we discussed the need to treat ballast water so that you don't inadvertently bring any marine life from one ocean or body of water to another. Can you tell me a bit more about that and how often the water is treated?
The ballast water regulations have been in place for quite a long time, and they started off with what they call ballast water exchange, and that was primarily to go from one continent to another. So if you went from the European continent and you went to Australasia, you would have to stop halfway there at deep sea, and you would pump out your ballast and pump in fresh, clean water so that you didn't transfer the organisms from one continent to another. That's been more refined, and now we have fitted ballast water treatment systems on all our vessels, and we treat the ballast both ways. And we treat it with an ultraviolet light. So as the water comes in, it passes through a very strong beam of ultraviolet light, which kills the organisms that are coming in, and we treat it on the way out as well. So it gets two treatments. The water coming in will be treated, it goes into the tanks, and then once we've arrived at the load port and we put cargo into the ship, we then to remove the ballast. As we remove that ballast, we treat it again going out.
It's really interesting. So many things that people wouldn't necessarily think are issues you need to think about at the end of the day.
Yeah.
So during our tour, there was a moment when Sebastian accidentally tripped an alarm on one of the doors. Now, he was able to switch it off straight away, but within seconds, he received a call from the bridge confirming that everything was okay and that there was no immediate problem. What I learned then is that on the bridge, there's an alarm panel which will notify the crew member in charge as to what the issue is and where on the tanker the issue is. Now, Sebastian even mentioned that the first officer had a similar panel in his cabin. Can you talk a bit more about this, as well as who on the ship has the ultimate responsibility for keeping updated on any issue?
The door that was passed through was a watertight door. So it was below the water line. Any door that opens in that area, so below the water line, when the door opens, there's a light in the signal is triggered to the bridge. So whoever is on duty will note that that door has been opened, and then they'll make sure that that door has been closed. So that's part of the safety systems within the ship. If you don't close the door, then you'll get a call to send you back, but the door should close automatically over a period of time.
When we were organizing the voyage, we became aware of the need for the vessel to be gas-free before we could bring camera equipment on board. Can you talk more about what gas-free means for a tanker and how the regulations vary from cargo to cargo?
The vessel that you boarded was classed as a chemical tanker, so she can carry flammable products. She had carried flammable products in the past, and so when you're carrying a product such as that, you can get vapors that are released out through the vents onto the deck. So if you're conducting any hot work, or you have what we call non-explosive equipment on board. So for example, when we take radios on deck, they're all explosion-proof radios, and any equipment that we use is carefully selected to make sure it complies with all the various regulations and is not it doesn't give off sparks. If you're going to have equipment on which isn't classified in that way, then you need to make sure that you're what they call gas-free. The gas-freeing term in the tanker industry means that you've emptied the tank of cargo, you've emptied the tank of vapors, so the flammable vapors, and the tank's been cleaned and the vapors have been dispersed, so that there's no risk of any gas pockets existing around the ship, so that if you inadvertently walk into that area with a piece of equipment which is not certified for use on deck in a flammable atmosphere, you won't get a spark and an explosion.
Good to know, thank you. And a follow-up question, if I may. Some of the crew spoke about gas-free operations and the need to stay behind closed doors when the ship was being ventilated. Is that the same issue?
No, that's the same issue. If we change grades, so some of the cargoes that we carry, once you've pumped the cargo out, you're left with the vapors in the tank, and you can get cross-contamination between the different chemicals. So we need then, as well as pumping away the liquid cargo, we then need to pump away the vapors that are left, so that the vapors can't contaminate the next cargo coming in. In doing so, we push the cargo vapors through what's called a PV valve, a pressure vacuum valve, and there's a gauze on that valve, which is called a flame screen, which stops any spark or flame going back into the tank and causing an explosion. So we vent and we push air into the tank and we push the vapors up, out and away. So when we're doing that, we have to keep all the doors and the ports and everything around the ship closed, and we keep people out of the way so that they don't inhale any of the vapors and they're left to disperse naturally.
So Sebastian mentioned that the first James Fisher vessel he sailed on used a different cargo, and that the Superiority was his first chemicals tanker. Now, when crew members switch between vessels throughout their career, do they need to be retrained for each different cargo?
In essence, yes. The cadet that you spoke to He'll be on a training regime. So we have a full plan of his college time, his seagoing time, which ships he's going to be serving on. And what we do is we make those line up so that when the sea time is finished, they have sufficient time on each of our different classes of vessel to collect what's called a dangerous cargo endorsement. So he needs time on a chemical tanker. And then at the end, when he does his certificate of competency, that will be endorsed with the chemical endorsement, allowing him to sail as a third officer or as a junior officer on one of our chemical vessels. If you were to go on to LNG vessel, you need a gas endorsement for a gas ship and an oil or dangerous cargo endorsement for an oil carrying ship. So there are different endorsements for different classes of vessel. Correct. Yes.
Obviously, the pandemic impacted every industry around the world, but I can't imagine the impact on your industry because, of course, the need to move energy did not stop. How did you match the need to balance crew safety with the standard health and safety requirements that you needed to meet?
A ship is a pretty much an isolated community in any event. There's a small crew on board the ship, and a lot of the time while they're sailing, they won't have interaction with other people because they'll be sailing as a team. So what we did was we identified the fact that every ship was going to be, as was termed at that stage, a bubble. So before you went into the bubble, you would be tested for COVID. So we had COVID tests on board. So if a new crew member was joining, they would come into one particular area which we had identified. They would be tested for COVID. Some of the tests take a long time to get the results, maybe an hour or so, but during that time, they would not be allowed into the accommodation of the ship. They'd have to wait there. If the test was clear, they would then go into the ship. For the off-signer, we would do a test as well before they set off on their journey, but that was how we protected the bubble. When we had pilots and other people who needed to come on board, again, we would try to test them. Some employers didn't allow us to do that, so we would keep a physical distance between the individuals. We would decontaminate the bridge area where the pilots would be, and anybody coming on board who hadn't been tested, we would ensure that everything was clean afterwards. So we would clean down and wipe down everything and disinfect everything. So what we did in essence was we preserved that bubble, and we kept everybody safe in that instance.
During the engine room tour, Sebastian showed me a tool called the sounding pipe and spoke about the various processes and equipments needed to check cargo levels and ensure that tanks aren't overfilled. Could you talk me through the specifics around storing and carrying cargo safely?
Yeah, we when we're loading a cargo, we practice what's called close loading. So the tank is battened down, and as you fill the tank with liquid, obviously the gas in the tank starts to get compressed. Now, all of our ships are fitted with what vapor return line, and where the shore allow that, the vapor is piped to the shore. So the tank that's being emptied is running down, so it has more space at the top, a vacuum, if you like. And our ship then allows that vapor to go to the shore and fill up. So there's, as one tank goes down and the other one comes up, our vapor's passed ashore. If we don't have a vapor line connected, because some terminals don't have that facility, we vent through a pressure relief valve, a PV valve, we call it, and that's designed to lift at a certain pressure, depending on the ship, and depending on the product, that will lift and that will vent the gas at a velocity that's faster than a flame burn down time. So a flame can burn through a vapor at a certain speed. The special valves, the PV valves, eject the gas faster than the flame can burn down. So even if there was a lightning storm that we didn't see and that gas plume caught fire, the gas would be coming out of the tank faster than the flame can burn down. So it would protect the cargo and the ship. We operate closed loading, and inside the tank there's a radar which is sending a signal, a pulse down, and it's reflected back off the liquid, and that's measured, and that comes back into the control room and tells the officer in charge of the operation how much, what we call ullage, how much of the the tank is left to fill. So that is monitored as the liquid comes up. Okay, so then we'll agree what they're going to be the cut-off ullage, and the chief officer will do those calculations, and they'll be left for the watchkeeping officer to follow, and they'll top off what they call top off. They'll stop the cargo at that predetermined ullage, which will be a certain tonnage in that tank. The sounding pipe that you referred to is a secondary means. And that secondary means is if we have a failure of the main system, the ullaging system, we can use a manual system where we put a meter on top of there, and we actually measure it basically with a tape measure, and that goes down, and there's a bob at the end, and as soon as it touches liquid, there's two little sensors, so when they're joined together by touching a liquid, it sends a small charge across. And then that gives a signal back, and it makes a buzzing sound, so that you just lower until you hear the noise, and then gradually you can follow the cargo as it fills the tanks, or you can lower your gauge to a predetermined depth, and then when the liquid comes up and it touches that, it will buzz, obviously, because you're coming up to the required level. So that's a secondary means. And when we're topping off cargoes, we use both. So you have the officer working with the ullage sensors, and then you'll have the AB on deck, and he'll be checking manually to make sure that they're cross-checked all the time to ensure that we don't overflow the cargo.
So layers upon layers of checking everything, double, triple checking everything for safety, really.
Yes, yes.
And then finally, you talked about some of the other roles you hold, including being the designated person ashore. Can you talk a bit more about that?
Okay. After a particular event that happened quite close to home, really, it was a Herald of Free Enterprise. There was an investigation. During the investigation, they identified that there was no one specific person who was senior within the organization that had overall responsibility for the safe operation of that vessel or the fleet of vessels. There then came out a set of legislation. It's called the ISM code. And under the ISM code, one of the requirements is that you identify a person who has access to the most senior levels of management and has the authority to either stop the vessel or to make changes to the vessel or to assist the vessel. And that's the role that I hold. So if a vessel gets into trouble and we need a tug, I have outright authority to order that tug, irrespective of the cost, to save the life and save the cargo and save the ship. So that's the role that I hold at the moment. And there's a deputy DPA who's Dan, and if I'm not available, then he'll be contactable. So we have to have somebody contactable anytime, day or night, 24 hours a day.
This has been fascinating, Cliff. Thank you so much for taking the time to speak with me today. And for all you other listeners and watching out there, thank you for watching. And don't forget to watch the next episode of our Voyage series. Thank you.